Hey folks, welcome back to Microsoft Connect. My name is Nate Barbatini and I'm a developer advocate at Okta, where I help developers learn how to build more secure applications. Today I'm going to be talking to you for a little bit about securing web applications that are built with ASP.NET Core 2.0. So security is always a fun topic and I'm really excited to dig in. This session assumes that you have a little bit of familiarity with ASP.NET Core 2.0. So if you don't know what ASP.NET Core is, or maybe you've used a previous version and you're not up to speed on the very latest version 2.0, I have something just for you. I recently released a book called The Little ASP.NET Core Book. This is a free ebook that you can download at littleasp.net/book. This book is going to take you all the way from zero if you don't know anything about ASP.NET Core, or maybe you've used a previous version. This is going to take you from zero all the way up to building your own application, publishing it on the internet, and teach you everything you need to know. So if you haven't used it before or you want a refresher, go download this book and then come back to this session where you can learn all about security. So what I want to talk to you for a little bit in this session is a few things. We're going to talk about the authentication system and authorization system in ASP.NET Core 2.0, which has kind of gotten a bit of an overhaul from previous versions. I'll talk about ASP.NET Core Identity, which is a system and a set of packages and templates that make it really easy to handle these authentication and login use cases in your applications. And then finally, I'll talk about hardening ASP.NET Core applications and taking what's kind of already a really secure framework and just locking it down even further and making sure that you're using every security best practice that's available to you. So I'm excited. Let's dive right in. I mentioned that the authorization and authentication system in ASP.NET Core has gotten a bit of an overhaul from previous versions. It's been refactored a little bit. Specifically, it's been refactored with an eye towards making it very modular and really easy to set up. So I'll kind of come back to this point a couple of times as we go through the code, but the authentication system specifically in ASP.NET Core is very modular and very kind of unopinionated about what types of authentication you might need to use in your project. So everything from simple projects that just need, email and password login and dropping a cookie in the browser to keep track of the user, over to Facebook or Google or other social login providers, all the way to using OpenID Connect to connect to a hosted identity provider like maybe Azure AD B2C or Okta. No matter what you need as far as authentication goes in your application, ASP.NET Core is going to be able to take care of it, and you're going to be able to plug into the same exact kind of generic authentication mechanism that you use for any authentication provider. And the same goes for authorization. The authorization framework in ASP.NET Core 2.0 has been evolved, and it's really modular and unopinionated as far as what you need to build in terms of authorization for your projects. So I always like showing code instead of talking about it, so let's jump right into the code and I'll show you how this stuff works from scratch. Okay, so I'm using Visual Studio here just because that's kind of what I'm used to, but you don't have to use Visual Studio. ASP.NET Core 2.0 is totally cross-platform, so if you prefer using a Mac or you prefer editing on Linux in Atom or Sublime or VI or VS Code or whatever your favorite editor is, you can totally use that. What I've done is I've just created a brand new kind of blank ASP.NET Core 2.0 application with Visual Studio 2017. These are the same templates that you can get from the command line if you use .NET New. But I've gone ahead and created a new ASP.NET Core application from the MVC template, and I specifically chose not to add any built-in authentication to this project. I chose no authentication. The reason I did that is because I want to kind of show you how the authentication system is built up from scratch. You typically wouldn't do this. Typically, you can start from one of the pre-built authentication templates, but I just want to show you it from scratch so you can kind of understand how all the pieces work together. So in this project, I've kind of cleaned up the default template a little bit. I removed all the boilerplate stuff in the home page, for example, and I just made it so that there's a really basic check here in the home page, checking whether the user is authenticated or not, and we're going to kind of flesh out this code as we go. But before we get to there, let me just go ahead and kind of spin up this application, compile it, and you can see how basic it is and how my web design skills have aged very poorly. Like I said, what I'm going to do is I'm going to plug in authentication into this project from scratch so you can kind of see how all the different underlying bits in the authentication framework work together in ASP.NET Core 2.0. So we've got this application coming up here in just a second. This is, like I said, just kind of the most basic ASP.NET Core 2.0 application template. I cleaned up the homepage a little bit, and we're going to flesh this out to add like a little login page, or if the user's logged in, we'll give them some information about themselves. So let's add authentication to this project. Over in the startup class, which is kind of the brain of any ASP.NET Core application, we have two kind of concerns that we need to take care of in the startup class. We are configuring all of the services that are used by the application, and then we're also configuring the application middleware, the pipeline that's used to handle incoming requests. So the first thing we need to do is add the authentication services to this project. Since I didn't start with any template that had authentication built in, that's not being done yet. So I'm going to do services.add authentication here in the configure services method. That just adds all of the kind of generic authentication services to this application, but it doesn't actually turn them on yet. What I want to do is specify a specific type of authentication I want to use. And just for the sake of a really simple demo, I'm going to show you how to use cookie authentication in this project. But the same kind of setup steps and the same principles apply if you're using Facebook or Google or OpenID Connect or some other more interesting type of authentication. So I'm going to do .add cookie. This is where you can plug in other schemes like .add Facebook or add OpenID Connect, for example. But I'm going to stick with cookies for now. Each one of these kind of authentication types are called schemes. And we want to let the authentication system know which scheme we're using as what's called the default scheme. In a more complex application, you might have multiple ways that a user can log in. So maybe they can use an email and password, or they can log in with Facebook or Google, or maybe something else like a federated identity. I'm going to let the authentication system know that cookies is my default, even though I only have one here. I'm going to say that the cookies scheme is my default authentication scheme. And instead of using a string here, I can just use this static class called cookie authentication defaults. Let me import that, .authentication scheme, which is just the kind of static string cookies. But I'm going to use this static class to refer to this a few other times in the application so that I don't typo it or mess it up. OK, so we've added the authentication services, and we've added the cookie authentication service specifically. But if I restarted this application and spun it up, there would be absolutely no difference yet, because I haven't added the authentication middleware to the middleware pipeline. So it's just kind of sitting there and not doing anything. In the configure method, I can add it to the pipeline, and I want to add it right above the place where it says use MVC. So the configure method is kind of order dependent. So the order that we're placing things in this configure method determines the order in which middleware are going to respond to incoming requests in the application. So it's important that I put this in the right place. And for the authentication middleware, the right place is right above the last stage of the middleware pipeline, right before the MVC system starts routing requests. So I'm going to do app.useAuthentication right here. This is actually a really easy step to miss. I've missed this a couple of times when I'm building applications, and then I'm wondering why my authentication doesn't work. That's because I forgot to add it to the middleware pipeline. OK, so we've added it to the pipeline, but it's actually still not going to do anything. We're still going to always be unauthenticated because we haven't actually given the user any way to log in. So I'm going to do that next. I'm going to build a really kind of bare bones basic login form here in the index Razor page. So I'm going to add that login form here. I have a snippet that I wrote earlier. And this login form is just going to be a very basic HTML form. It's going to say, hey, let's enter your name to log in. This is an HTML form with an action of login, which is going to hit a login action on my home controller, which I haven't written yet. I'll write that in a second. I have just one HTML input tag called name and then a submit button. So as you can see, this is obviously not a production-ready login screen. I'm not asking for a password. I don't really have any security around that. I'm just doing this super basic to kind of show you how the underlying systems work, and then you can use the same underlying patterns to build authentication in your own applications. But let's say that we are going to go with this very basic login form. I need to create that login action that this form is going to post to on my login controller, on my home controller rather. So let me go to my home controller here and insert a login action. I need to import a couple of namespaces here that are missing. And then I'll explain what this code is doing. So I have a login action that's going to take just a single string name. That's going to automatically be bound to the name that's being submitted from that HTML element called name, the input tag. I'm going to do a quick sanity check to make sure the user isn't doing something weird and like submitting the form empty. And assuming the user entered a name, what I need to do is build up an object that represents the user's information to ASP.NET Core. And the type of object I need to create is what's called a claims identity. This is a particular way of representing the user's information in what are called claims, or just key value pairs. And the only key value pair I care about right now is just their name, because that's all I have. But in a production application, you would typically pull more information maybe from your database or from an identity provider or something and build up a claims identity with more information about the user. So I'm creating a claims identity just with their name that they entered, and then I'm specifying that this identity is tied to the cookie scheme. I'm using that static class again here. I'm also kind of wrapping up that claims identity in a claims principal, which just represents the user. And given that, I'm ready to log the user into ASP.NET Core. I do that with this HTTP context.signin async method, which takes two parameters. One is the authentication scheme again that we're using, and then secondly is just the principal that represents the user. So you can see here kind of what I was talking about before. The authentication system is really generic, and it's really unopinionated as far as what method or what type of authentication you're using. It doesn't really care that I'm using cookie authentication. It could be some other type of authentication. This sign-in async method just says, OK, tell me the scheme you're using and what's the user's information. Give me that principal. After I do that login, then I'm redirecting back to the index page, and that check I have in the index view that checks to see whether the user is logged in is now going to return true. So that takes care of the login action. I'm going to go update that index view so that if the user is logged in, we can show them some new stuff. So I am going to show the user two things if they're already logged in. First, I'm just going to tell them what their name is. Kind of obvious. Hopefully they know that already. And then I'm also going to show them a log out form, so a button that just says log out. That's another HTML form that's going to post to a different action called logout on the home controller. I haven't written that yet, but before I get too far down the road, I want to just demo this and show you how it works. So let's spin up the application again. And what we should get is a pretty straightforward login form that you should not use in production. And I'll just enter my name here to log in. When I click Login, it's going to immediately log me in. I'm getting that logged in view already, and it's telling me that I'm logged in as Nate. Now, under the hood, ASP.NET Core is delegating to that cookie authentication service. That all kind of happened under the hood without us really having to worry about it. If you really wanted to take a look, if we open up the developer console of the browser here, and then take a look at the application tab and what cookies are currently stored, we can see that there's a cookie called ASP.NET Core.cookies. And that cookie wraps up a number of other items, but that cookie includes the information about the user that we just created, and the cookie middleware is injecting into this browser for us, or rather saving as a cookie in this browser for us. If we log out, you'll notice that that cookie is going to go away, or at least become a lot smaller, because it's not storing the user's information anymore. Of course, I haven't actually written that logout method yet, so logout doesn't do anything. Let's go write that logout method. Compared to the login method, the logout method is actually pretty straightforward. All we have to do is call sign out async on the HTTP context, and again tell it what scheme we're signing out of. you can see here that if you have multiple types of authentication in your project, maybe cookies and Facebook or cookies and some other external login source or something, you can get pretty granular about how you're signing out. So you can say this user is signing in by this method, but this other user is signing in with this other scheme. OK, that takes care of the log out route. Let me run this one more time. I'll leave the developer console open so you can kind of see what's happening this time around and see that cookie being dropped into the browser by the cookie service. So I need to preserve the log here, and then I'm going to sign in as Nate again. If you take a look at the request, the post over to the login action, you'll see that it came back with a cookie. And then the same exact thing is going to happen if we hit log out. It's going to delete that cookie, or rather probably make it a lot smaller. Where's log out here? There's log out. Yeah, now the response is a lot smaller or null. So that's a very brief overview of how the cookie authentication works in ASP.NET Core 2.0. Obviously, the cookie middleware is pretty straightforward. It's pretty basic, and this is not something that you would typically do from scratch in your applications. What I wanted to do, though, is show you those underlying methods like sign in async and sign out async, and show you how the schemes kind of tie into that, because those same exact methods are used no matter what type of authentication you're using. Whether it's really simple like this, or it's a lot more complicated, you're still using all of that underlying kind of generic framework to make it work. So that's a little bit about authentication. Let's talk about authorization. So authentication is concerned with whether the user can log in and who just logged in. Authorization is concerned with, does the logged in user have permission to go do a particular thing? And there's a lot of different forms of authorization. Authorization might be claims-based authorization, where you are evaluating some of the properties about the user to decide whether they're allowed to access a particular thing or see a particular resource. There's also role-based authorization, where you're taking a look at the user's role. So like maybe only admins can view a particular site section and normal users can see something else. There's also more kind of advanced stuff like resource-based authorization that depends on specific resources that the user is trying to access. But no matter what type of authorization you're trying to use in your ASP.NET Core application, the kind of generic authorization system is going to be able to model what you need. And I'll show you exactly how that works. So as a very basic kind of demo, let's imagine that we want to make a new section of the site called like Manage Your Account. And that will only be accessible if you have logged in already. We don't want unauthenticated or anonymous users to log in and see that, or be able to see it without logging in, rather. So I've created this view called Manage, which just like shows the user their name and whether they have a role or not. And I need to create an action on the home controller that, that points to that view. So let me collapse these sections here real quick. And I'm going to create a new action called Manage. So this will just be iActionResult Manage. This will return a view. And instead of just leaving it like that, I want to make this kind of require authentication to log in. So to do that, I'm going to add this attribute called authorize. This authorize attribute is kind of the basis of how you'll do any authorization checks in ASP.NET Core at either the controller level or the action level. I'm using it at the action level here, but I could apply it to the controller as well. So this authorize attribute, without adding any other additional parameters to it, this authorize attribute is just going to check whether the user is logged in or not. And if they're not logged in, it'll fail the authorization. We can also add more properties or parameters to the authorized attribute to do things like checking particular authorization policies. But before we get into that, let me just show you the kind of basic case. I'm going to make one other change to this project in order to make it a little bit more obvious how the authorization check is happening. So in this cookie middleware, or the cookie service rather, I'm going to say add some options. And I'm going to add two options here. Access denied path and login path. The access denied path is where the application is going to redirect to if you're logged in but you fail an authorization check. And the login path is where the application is going to redirect to if you are not logged in and you need to be logged in to see a particular thing. The kind of default behavior for this is to try to redirect to a login screen, but we don't really have a login screen in this demo because I just kind of made one up from scratch. So I'm changing this just to make the demo a little bit more obvious. I've also created 2 views, error forbidden and error not logged in, that should make it really obvious how these authorization checks are failing. So if we run this project, the expected behavior for now is that if I'm not logged in, I should not be able to access that manage action. But if I am logged in, I should be able to access it. Let's try the simple case first. We'll just try to go directly to home/manage, and I should get the forbidden, or rather the not logged in error. So it says you must be logged in to view this page. That's exactly what I was expecting. Let's try logging in. And actually, it would be a lot easier if there was a link here. So let's add a link real quick to the index page. Let's say that if you're logged in, you're going to see a new link that just points to that manage action. And we'll say maybe manage your account. All right, refresh, and there you go. So since I'm logged in, I should be able to access the manage page, and there we go. Just for the sake of the completeness, let me log out again and just prove that I can't access that page. Home/manage error. OK, perfect. So that's a very basic authorization check, just whether the user's logged in or not. Let's try to make it a little bit more interesting. So let's imagine maybe we want to change that authorization check to be not only just is the user logged in, but maybe they have to be an administrator to see that page for some reason. So what we can do is build what's called an authorization policy that lets you roll up whatever authorization requirements or checks you need to do up into one kind of reusable policy that you can use throughout your entire application. So what I'm going to do is modify this authorize attribute and specify a policy, which is just a string name that I need to specify. So I'm going to say the policy is like must be admin. Now I need to go create that policy because right now it doesn't exist. That's done in the startup class. So in the startup class, once again in the configure services method, I need to configure the authorization service, which doesn't currently have a line in here, but we can just add one, services.add authorization. And we need to pass some options to the authorization service. So we'll say options.add policy. And I called it must be admin. And now we get access to this policy builder. So we can say p lambda p dot, and we get access to these authorization requirements like require authenticated user. That's kind of a given. We'll say require role admin. So this will require that that user has to have the role called admin to be able to access this action. Now, these authorization checks here are kind of basic, role check, claims check, required to be authenticated. But if these aren't enough to kind of compose the authorization requirements you need for your particular use case, you can just create your own custom authorization requirements that plug directly into this same exact builder system. So it gives you a lot of flexibility for defining whatever authorization requirements you need to set up. So we've defined this must be admin policy, and we've applied it here in the authorize attribute. So now, when I run this, the new expected behavior is, of course, I still won't be able to access it if I'm not logged in. If I am logged in, though, I'm going to get a forbidden message because while I'm logged in, I'm not an admin role. So if I log in here and then try to manage your account, it's going to fail because I'm not an admin. Let's go make me an admin and see if we can get past this authorization check. So in the place here in the login action where I'm kind of building up that claims identity, I'm just going to add a new claim that says I have the admin role. Super easy. Again, something you wouldn't do in production. You would probably be loading these from like a role table in your database or something. But for the sake of the demo, I'm going to now be an administrator. And now I should be able to get right past that authorization check, and it should show me that I'm an admin role. There we go. Almost done. All right, there we go. So I'm an admin role. I was able to get past that authorization check successfully, and that's how the authorization system works in ASP.NET Core. Obviously, the rabbit hole goes really deep on both of these things. Authentication and authorization are not, simple topics, but the kind of unopinionated generic framework that ASP.NET Core gives you for both of these things makes it really easy to kind of compose together whatever unique needs you have for your application and your use cases. So I want to talk a little bit about ASP.NET Core Identity. ASP.NET Core Identity is something you may have heard of already. It's a modular membership system, which is just a fancy way of saying it handles a lot of pre-built stuff like really common use cases like login, registration, password reset, all that stuff that you would typically need in a web application. But ASP.NET Core Identity isn't like magic or anything. It's just a set of classes and pre-built code that sits on top of those base authentication and authorization components that you just saw. So ASP.NET Core Identity gives you a lot of this functionality out of the box, and you don't have to write it from scratch. But under the hood, it's just calling into those methods like http context.signin async, .signout async, etc. So let me show you real quick what it looks like when I say you have some pre-built functionality. So if you create a new application from the ASP.NET Core web application template, but you pick user authentication or individual account authentication, or maybe one of the federated identity authentication options, when you create an application from that template, you get what you just saw in my previous application, plus a lot of extra stuff. You basically get a ton of stuff given to you by ASP.NET Core Identity, because those templates that include authentication pull in ASP.NET Core Identity automatically. So this is an example of what you get. So you have a bunch of controllers that are created by the ASP.NET Core Identity template for you. And this handles a ton of use cases like login, registration, logging in with two-factor authentication, password reset, all that good stuff. Hopefully you can see that this is not some like magical thing that just works. It's just some code that you could write yourself that works on top of the authentication system and authorization system that I already showed you. But instead of writing all that code yourself, why don't you just pull in ASP.NET Core Identity and you get most of that code written out for you automatically. So that's pretty awesome. All right, so moving right along, I want to talk a little bit about hardening ASP.NET Core as well. So ASP.NET Core is a pretty secure web framework already. The team at Microsoft and all the open source contributors have done a really good job of making sure that security is a really big, high-level concern in all across ASP.NET Core 2.0. But there's always stuff that you can do in your own applications to just make sure you're using all the best security practices. So specifically, 3 things that I'm going to talk about here. I want to talk about anti-forgery or CSRF protection. I'm going to talk about HTTPS, or encrypting the connection to your application. And finally, I'm going to talk about security headers, or turning on some optional security functionality in modern browsers. So I like showing code instead of talking, so let's go ahead and switch back over to the code, and I'll show you what this looks like. First of all, let's talk about anti-forgery, or cross-site request forgery protection. That's a mouthful. Anytime you have a form, any type of HTML form like this one, where you're posting to some place in your application, you need to be aware of preventing what's called cross-site request forgery. That's a really fancy way of saying that when you're accepting a form post in your code, you want to make sure that those form posts are always originating from your site and not from some malicious site. Because if you don't check for that, a malicious site could trick one of your users into posting some data to your site that they didn't want to post, or doing something else bad by posting data to your site. So preventing this attack is typically referred to as anti-forgery. And ASP.NET Core has a lot of this built in. Kind of right out of the box, you get protection for this anti-forgery attack, or for this cross-site request forgery attack, rather. Without even having to do anything, ASP.NET Core is using a best practice and injecting what's called an anti-forgery token into my form. You can't see it here, but anytime I open up a form tag in an ASP.NET Core application, I'm getting an anti-forgery token built in automatically. So that's really cool. That's kind of the best practice, kind of industry standard way of preventing this type of attack. However, there is one thing that you have to do on your end in your code to make sure that you're validating that token. So like I said, the token's already there in the form, but in your action that you're accepting that form post to, in our case it was the login action, we need to make sure that we're validating that form on the other end. So all that means is that we need to go in here and do validate anti-forgery token, which tells ASP.NET Core to not only put the token in the form, but then when it's submitted, validate it to make sure it's there and it's valid. This prevents someone from, on another domain or on a malicious site, from posting the form maliciously because they won't have access to a valid token that your application is generating. So this is pretty cool. This is kind of the industry standard way of solving this particular attack. And the only problem here is that you kind of have to remember to place this attribute on any post action or any place in your code where you might need to validate a token. There's a better way to do it. We can actually use, in the startup class, we can actually use a particular line of code to apply it to the entire application automatically. So instead of putting it here, I'm actually going to apply it once and for all in the startup class. So that's going to be done, like many things here in the configure services method. In the add MVC line, I'm going to configure the MVC system and add what's called a filter. I'm going to do options.filters.add, and then I can just do new validate anti-forgery token attribute. What that's going to do is basically behave as if we're applying that attribute across all of the actions and all of the controllers in this project, except we only have to do it once, and it's only one line of code. Now, there's only one problem here. This is actually a little bit over-enthusiastic, because applying it to every controller and every action means that we're also applying it to like get actions and things that don't need a token to be validated. The token should only really be validated on methods of HTTP verbs that mutate state. So we have things like the HTTP put, post, and delete are the types of actions and verbs that we should validate this on. So what the kind of elegant solution that the team came up with is that you can simply apply auto-validate anti-forgery token attribute instead of anti-forgery token attribute. This kind of auto variant will automatically ignore get, trace, options, head, those kind of attribute or those HTTP verbs that are kind of safe verbs and don't need to be validated, and it will correctly apply them to put, post, delete, etc. So with that one line of code, we've protected against cross-site request forgery attacks, which is awesome. The next thing I want to talk about in the kind of hardening topic is HTTPS. So by HTTPS, I mean SSL, TLS, this idea that you're going to encrypt the connection between the browser and your application or your server. So it used to be that HTTPS was kind of a pain in the butt. It used to be really expensive. You had to shell out like $500 a year or something to like VeriSign and buy a certificate. And you had to figure out how to set it up in your server, and you had to deal with the fact that sometimes it slowed down older browsers. But all of those concerns have pretty much been mitigated now. You can use a service like Let's Encrypt to get SSL certificates totally for free. ASP.NET Core makes it really easy to put HTTPS into your project, and it doesn't slow down browsers anymore. So the kind of industry best practice and what I recommend is just having HTTPS on whenever you're building an application. What we can do here in Visual Studio is turn on HTTPS by right-clicking on the project in the Solution Explorer and clicking on Properties. And then just tick this Enable SSL box here, and we get a new port that's going to be the port that HTTPS is running on. And I can show you that if I start up the project. Basically what we're going to have now is the project is still going to be hosted on HTTP on one port, and it's going to be available over HTTPS on a different port. And I'll show you both here. So here's our HTTP site running on 63.896. What was the port that we got here? It was 40-something. Let me go back to this properties. 44.327. So if we switch over here to HTTPS 44.327, we should get a green secure lock in the browser, and now we're hosted on HTTPS, which is great. We can take that a step further, and instead of allowing the browser to connect over either HTTP or HTTPS, we can just say you have to connect over HTTPS, and if you try to connect over HTTP, you're going to get redirected. So let's do that. It's very similar to the anti-forgery token attribute. On controllers or actions, we can apply this attribute called require HTTPS, which for this controller or this attribute will force the browser to connect over HTTPS, and if it doesn't, it'll redirect it to HTTPS automatically. And you might see where this is going, just like the other attribute we were talking about. It makes a lot more sense just to apply this to your entire project at once with one line of code as a filter, instead of having to remember to put it on every controller. Because I know me, I'm going to forget to put it on one. So let's do that here. Let's do options.filters.add new require HTTPS attribute. And that's just going to apply it to all of our controllers and all of our actions automatically. So if you notice here, when I run this application one more time, it's going to actually fail to connect over HTTP because that's not available anymore, and we'll be able to only connect over HTTPS, assuming I get the port correct. There we go. We have HTTPS running on 44.327. OK, so HTTPS is great. You should definitely use it in your project. There's one more thing we can talk about to kind of lock down the security of your application even further, and that's HTTP security headers. If you're not familiar with HTTP security headers, the idea here is that modern browsers have a lot of optional security features that are not turned on by default, but that applications can kind of opt into by returning specific headers with the HTTP response. So your server's already returning a bunch of headers like content type, content length, the host header, all sorts of stuff. But if you return specific other headers that modern browsers are looking for, they'll turn on additional security features, which is great. There's a really great tool that you can use called securityheaders.io, which I'll show you here. Which is basically a way that you can just scan your site or scan your application to see what security headers you're returning already and some recommendations about what you should return to make your security even better. So I want to scan this site that I'm building right here and see what my security headers look like and if I should add any. Securityheaders.io won't be able to scan my site if it's just on localhost, so what I need to do is kind of open up a tunnel so that it's routable on the public internet. I can use a tool like ngrok or localtunnel.me in order to do that. What I'll do is I'm going to spin up this application, and then I'm going to use ngrok to open up a tunnel, and I'm actually going to give it the HTTP port, not the HTTPS port. And I'll explain why in just a second. Let me open up launch settings here. It was 63.896. OK, so if I create a tunnel to localhost 63.896, then I get this random URL generated by ngrok, and I should be able to access that online over HTTPS. And there's my site running on HTTPS, routable on the public internet. So if you're watching live, you can try to log in if you want and try to break my site. You might be wondering why I was able to route to this site if I was using the HTTP port. The reason for that is a little bit technical, but ngrok is basically doing SSL and then terminating SSL before it gets to my application, just like a load balancer does in like a server farm. And because I'm doing that, I need to add a particular middleware to my startup class called, I'll show you it right here, called use forwarded headers. And this is just kind of a standard way of handling this situation where a load balancer is terminating SSL for you. But with that, the require HTTPS attribute is satisfied and everything works just fine. But getting back to the security headers topic, I'm going to take this URL and then scan my site with securityheaders.io and see kind of where I'm at. Well, that didn't work. Let me try again. Okay, so I have a D, not super great. SecurityHeaders.io is telling me that there's a couple of headers that I should be returning for maximum security that I'm not currently returning. And what's really helpful about this site and why I like it so much is that it tells you exactly what you should add or what the recommended settings are to get these headers on your site. So I want to add a couple of security headers to my site, and the really easy way to do that in ASP.NET Core is with a package that's available out on NuGet called nwebsec. So I'm going to go add that package from NuGet. I'm looking for the package nwebsec.asp.NET Core or ASP.NET Core.middleware. So I'm going to install that. And all this middleware does is a really lightweight package that basically lets you plug into the configure method in your startup class to add a lightweight little middleware that returns these security headers from your ASP.NET Core application. So in the startup class, let's add a couple of these. So one of the recommendations from SecurityHeaders.io is that we return the strict transport security header. The strict transport security header is a really cool header that basically gives you an additional check or additional enforcement of your HTTPS site. So we're already returning the site over HTTPS. We're also redirecting from HTTP to HTTPS. So if someone tries to access it over HTTP, the site is going to redirect after the first time they connect. However, that does still mean that they're going to connect at least one time over HTTP. So maybe they're connecting over HTTP and then that request gets redirected to HTTPS, but they still have that initial one. So if we return the strict transport security header, sometimes called HSTS, we will be telling the browser that, hey, please don't ever let anyone connect over plain HTTP. We only want to connect over HTTPS. So this is pretty cool. We can do app.usehsts. And then we can give it a couple of options. We can tell it how long this kind of policy is supposed to last for. So let's say max age of maybe a year, which is pretty common. And then we also want to say that we want to apply this to all the subdomains of the application as well. So again, returning this header just means that the browser now will be kind of enforcing us only serving content over HTTPS. And if someone goes in and tries to delete the S and manually navigate to the HTTP URL of your site, they won't even get to the point where your site is redirecting them. The browser will just force them to connect over HTTPS. So it kind of closes a loophole that's sometimes referred to as trust on first use, or TOFU, which is making sure that there's not even a first connection over HTTP, that's always over HTTPS. And additionally, an additional feature of this kind of strict transport security header is that you can opt into something called the preload list. The preload list is a precompiled list of all these sites that should only ever be connected to over HTTPS. And that's actually downloaded into Google Chrome or into your browser automatically. So you can opt into this preload list with your site and say, hey, don't ever let anyone connect over HTTP. I never want that to happen. I only want HTTPS, which is pretty cool. So let me rerun this application. Now that we're returning that header using nwebsec, using that little usehsts middleware, we should get a slightly better result, at least on securityheaders.io. Let me wait for this to come up and refresh, rescan. When this comes up, OK, we're still a D, but at least we have strict transport security turned on. So we are returning a proper strict transport security header, which is saying for a year, telling the browser basically for a year after seeing this header, don't ever connect to this site over HTTP, just HTTPS. So there's a couple other ones we can add here. A lot of these other ones are pretty easy to configure as well. Let's say we want to return the XXS protection, that's a mouthful, XXS protection header, which turns on some additional cross-site scripting prevention measures in modern browsers. So we'll do use XXS protection. And the recommended setting here is enabled with block mode. And let's say we also want to return the use X content type options header, which doesn't require any configuration. This prevents attacks where sometimes browsers are tricked into treating data coming back from a website with a different content type than it really has. So just closing a lot of little loopholes in browser security. All right, when we have this running, let's rescan one more time and see if we could improve this score. I'm basically using securityheaders.io as kind of my unit test for my site security as far as security headers go. Now I have a B, so that's better. I could implement referrer policy. I could also implement content security policy. But you can kind of see how it's not too hard to add some additional security headers to your site to make it even more secure. There's one final thing that we could do, which is super easy. One of the other recommendations here is that we should remove the server header. Right now, all sites return a header that just says what server they're running on. In this case, we're running on the Kestrel server, which is the kind of built-in ASP.NET Core web server, or the default web server, rather. It's generally a good idea to not let malicious actors or attackers know what server you're running on, just because you're giving them more information that they don't really need. By knowing what server you're running on, someone might be able to figure out what attack to use. And I'm sure that a really dedicated attacker would probably be able to figure it out anyway, but why give someone more information? So we can turn that off super easily by going into the program class here, which you don't typically have to modify, but this is one place where you can modify it. We can do use Kestrel, pass our kind of common options syntax here, and say options.addServerHeader, false. And we'll no longer return that server header. So at least it won't tell someone that we're running on Kestrel. OK, so that's a couple of ideas. Hopefully you got some ideas on how to make your websites more secure that are running on top of ASP.NET Core 2.0, as well as kind of a fundamental understanding of how the authentication and authorization systems work in ASP.NET Core 2.0. I'll give you a couple of takeaways, and I'm also happy to take any questions you have too, so submit them during the stream. A couple more resources for you. If you want to learn kind of the basics of ASP.NET Core, like I said, I have a free ebook available at littleasp.net/book. So if you've used an old version of ASP.NET, or maybe you've never used ASP.NET, check out the book. It'll teach you everything you need to know about the basics, and then come back and watch this security talk. There's also a ton of other information and content available on Channel 9, on the Channel 9 website, from this Connect event and from other events here at Microsoft. And there's tons of content available on the Microsoft Virtual Academy as well. So that's what I have for you today. I'll take a couple of questions while we have time, and I appreciate you tuning in. One question we had was, can we use the same or kind of to secure the same type of security or similar to secure ASP.NET Core Web API? So the short answer is yes. So typically when you're talking about an API, you obviously still need security. Typically it's not going to be like cookie security, but you'll typically use token authentication. So just like I showed plugging in the cookie services to the authentication mechanism, you use the same exact pattern to plug in what's called the JWT bearer authentication service. And then you can validate bearer tokens that are JWTs, which is a really common way of doing security for APIs. Another question is it the same steps to add authentication and authorization to a Razor project? And yeah, so like a Razor Pages project is kind of the same fundamental architecture. The view and front-end stuff is a little bit different because it's using Razor Pages, but under the hood, it's all the same bits in ASP.NET Core. So you can use the same stuff to set up authorization and authentication in a Razor Pages project as well. Send me any other questions you have, but other than that, thanks so much for your time, and see you next time.